Good morning. Today in the third module of semiconductor, we will like to discuss the p-n junction, the most important and conceptual concept of semiconductor, solid state semiconductor is p-n junction. Now, it is very unfortunate for our country that we are fourth position in software development, but we are nowhere in hardware development. The first step of hardware development or device formation is a p-n junction. No single industry in India till date, industry mind it, not lab, industry is here, so that they have to prepare a p-n junction, that is solid state diode. No, it is not. So, it is very unfortunate. After continuous effort, no industry is till date ready to make any industry in India, so that the hardware manufacturing is going on. Today our industry minister, humble Piyush Goyal sir, who is also in charge of railway, said that no longer India will be hub of assembly. Now the industry must have to transfer the technology know-how. This is a very big statement for the development of. From 1948, the semiconductor and solid state devices are under the process of fabrication. But till date we are not in the state to fabricate at a commercial level, but industrial level there are two centers, or there are another center also, that is two centers are ISC Bangalore or IIT Bombay. These two centers were established in 2008 under the nano mission scheme of DST, Government of India, with the funding of 200 crores each at that time, and now they are functional. They are giving training. We have completed the hands-on training and the project over there. So, after the project hands-on training, it is now clear what is p-n junction. Before that, it was not clear to me as well what is p-n junction. Now, from teaching point of view, tutorial point of view, what the p-n junction is given. In p-n junction, the definition of p-n junction is when a p-type extrinsic semiconductor is placed along with n-type semiconductor, then there is a formation of p-n junction. As from this definition and this diagram, this is p-type semiconductor, this is n-type semiconductor, and these two different extrinsic semiconductor are placed, what we say, placed along with. Placed along with means something like that, okay, this one is a p-type and this one is n-type. So, this is something like this, it is a p-n junction. The definition states this kind of the concept, which is wrong. The correct one is there is a fabrication technology. What is fabrication technology said? The fabrication technology state that this is a wafer SiO2 silica wafer, say n type. Then in this wafer, this part is taking out. this part is taking out, means the part is the material is taken out from this part. So, this is the structure. So, what we have, if you say from the dimension point of view, this is 50 micrometer, this is 50 micrometer, and say here it is 40 micrometer, this is the dimension, and definitely something like that. This is the 50 and this is the 40 micro, then width also is there. Here we are not concentrating on the width, we are just concentrating on the length and breadth of the silica wafer. So, in this N type silica wafer, there is a process of CVD. CVD is, the C stand for chemical vapor deposition, CVD means the vapor form of the for P type vapor form of phosphorus and Si, these two vapor form of phosphorus and silica are deposited in this space. Since chemical vapor deposition is a slow rate, so in order to accelerate the rate, we use, this is P. P stand for plasma, PCVD, plasma enhanced chemical vapor deposition. So, rate is fast. So, what we have, this whole thing is computerized process. Computerized process is fixing of temperature, pressure, composition, etc. All these parameters are fixed by the automatic computer machine. So, what will happen? There is a deposition of the vapor form of silica and phosphorus. So, what will happen? This vapor form, when this vapor form is come, then it start of depositing here. This start of depositing here. This portion, which was the empty portion, was filled with the chemical vapor deposition, and after the filling, we can express this concept as this is something like P type material due to the presence of phosphorus, due to the presence of aluminum trivalent and trivalent indium, as it is here in case of P type. So, all these part are considered as whole, and this was N type, this was the N type material. So, these are electrons, here it is holes and these are the electrons. So, this one is the actual picture of a p-n junction. Now, where it is junction? This whole interface is the junction. This whole interface is junction. This is something like this kind of the things, and we cut it and filled that. So, this cubical form or this form is the junction. Now, in order to simplify this concept, we are taking this one is p type and this is n type. This can be taken as a small portion. This is p and this is n. This is taken as the small portion. So, in this small portion, this part is electron majority charge carrier. Here it is holes majority charge carrier in p type, but there is a electron as well. Some electrons are also there, that is electrons, and here it is holes as minority. This electron is minority charge carrier. So, what we find in these two extrinsic semiconductor, the density of, in this case, density of electrons which is responsible for the movement, say d E in this n side, and here it is d P, density of electron in p side, or you can say d n, n side and p side, electron density. So, the density of electron in n side, dn is greater than dp. dn is greater than density, means the density of electron in n side is greater than the density of electron in p side. So, there is a difference of density across the junction, and when there is a difference of density, then there is a process. This process can be understood in a very easy way, that if you have something material which can burn and it spread, something like you say agarbatti stick. So, what will happen? This portion, that part, that atoms where density is very large, used to diffuse from one place to another place. So, in the same way, there is rate of diffusion, as in case of gas, it is Graham's law of diffusion. The rate of diffusion is directly proportional to the depth of density. So, this electron has the density and this has tendency to move in this way, because here it is high density, here it is low density. So, these electrons across the junction try to diffuse, move from n side to p side. This is. So, this process, the process that is happen is known as diffusion. Diffusion due to density difference. So, what will happen? When one electron from n side leave this sheet and comes to the p side. So, here it is lack of electron and here it is excess of electron. So, lack of electron is positive center, excess of electron is negative center, because the corresponding proton inside the nucleus is there. So, there is no movement of nucleus, there is only movement of electron from one place to another place. So, the first row where there is a lack of electrons are positively charged something like this due to the diffusion process. And where the electron occupy this space, these are the negatively charged. So, the first layer across the junction in this is N type, here it is P type, become a positive layer, and in P type this become a negative layer. So, this one is diffusion of first layer. What about the second layer in N type? The second layer, this electron also try to diffuse across the available hole. This electron also try to diffuse across the hole. This electron also try to diffuse across this one. This electron also try to diffuse. So, the second layer electron also try to diffuse into the hole of the second layer of P type. So, what will happen? This second layer where there is lack of electrons are positively charged ion, and here it is negatively charged ion. So, what is the difference of the process? If you say this one is, this rate of diffusion is R1, here it is the rate of diffusion is R2. So, we say diffusion of R1 is greater than diffusion rate of R2. Means the first layer diffuse quickly and the second layer diffuse relatively slow speed in comparison to the first layer. Now, this is the diffusion of two layers across the junction. What about this electron, the third layer? This electron have the space of here. So, if you say something like this, if you say this one is something like this, if you say this is diffusion across this, if you say this is diffusion across this layer. So, what will happen? Again there is a positive layer across the junction in this side, and here it is corresponding negative layer. This is corresponding negative layer. So, this rate is R3. So, what we feel? R1 is greater than R2 is greater than R3. First layer quickly diffuse, second layer diffuse with a time slower than the first, and the third is slowest rate of diffusion. So, this slowest rate of diffusion means you can demark this portion in the p-n junction across the junction that this region is positively charged, and this region is negatively charged. This region is negatively charged. So, one important thing that I have mentioned earlier, there are 4 symbols in the diagram. The first symbol is this one, which is electron. The second is this one is hole, and third one is this is the fixed positive charged or ion. A fourth symbol is this is the fixed negative charge or ion, negative charge or ion. So, there are 4 symbols represented in this diagram. So, now the one thing also, why the rate are varying? The rate are varying due to the, when this electron try to diffuse across the junction, then electron is negatively charged particle, and when try to diffusion there are electrons in the surface. So, these electrons also apply a repulsive force to the electron from N type to P type, and that is why this repulsive force slow down the rate of diffusion, but after a certain layer this process is stopped, and this process is stopped, and this width is Wn and here it is Wp. This is the width, this is the width. This width is also this width is also, this whole width is known as charge depletion region, in short CDR. This CDR is equal to, this is width of P side and width of N side, that is potential barrier. This width is the potential barrier. Now, due to the formation of this CDR region, the charge distribution across the junction this is your P type, here it is N type, and this part is junction. Here it is negatively charged particles which are fixed, immobile, and here it is positively charged ions which are immobiles. So, for sake of various calculations, if we have this one is a this is dimension, so something like the concept of this is developed. Here it is positive ions across the junction, and here it is negative ion across the junction, this negative ion across the junction. In this case, when due to this charge across the junction, there is a junction potential as well. This junction potential is something like, this is negatively charged, this, and here it is positively charged of this. This is positive and this is negative. It is known as junction potential. This is Vj. It is represented as the Vj, and this play very important role for the motion of charge carriers from one place to another place. Now, suppose this potential, that is Vj, that potential develop is something like this. This is your Bj. This is your Vj. If we say this is potential, so this electron, the electron from N type, electrons from N type try to move across the junction, but due to the potential, this will not possible to move the electron from N type to P type. So, this one is electron barrier. This part is known as electron barrier. Similarly for the holes, this is hole barrier Vj, this is hole barrier, because this hole this hole, the holes across the P side also try to move across the N side, when these are the holes, these holes try to move in this direction, then again they form a barrier. So, these barriers, potential barrier, restrict the motion of charge carrier from N side to P side for electrons and from P side to N side for holes. So, what ultimate going to happen, the movement of charge carrier going to stop, the movement of charge carrier going to stop. And one important thing is, whenever we talk about the component, circuit components, so this diode p-n junction diode is termed as active component. Active component due to this Vj, junction potential. So, right from starting with the first component, that is diode, is it is symbolized something like this. This is N and this is P. So, this first p-n junction diode symbolizes, this is the P, this is the N, is active component of the circuit. Now, the question is, if it is active component, what about the other family of the components like transistor, FET, IC? All these are active components, because somewhere there is a junction. Whenever there is a junction, then there is a development of a contact potential. So, potential develop. Due to the development of this potential, these components are termed as active components. And the other components of the circuit like resistance, capacitance, inductance, these components are termed as passive component. Why? Because there is a no potential across the resistance, capacitance and inductance itself. That is okay.